3 factors that affect solubility. Factors that affect solubility. In other words, what makes one thing soluble in something else? One of the first factors is that rule of like dissolves like. Y'all heard that before? What does that mean? Have we heard that before?
Yeah,
I think I've said it. What does that mean? Exactly. Exactly. It goes back to all those intermolecular forces. And if this one's polar and that one's polar, they're soluble in each other. Like dissolves like. If one's polar and one's nonpolar, like oil and water, well, they don't dissolve in each other. Okay, so that's what like dissolves like is. If 2 different compounds have the same types of intermolecular forces, they're more soluble in each other. The second thing that would affect solubility is temperature. How do you think, or what kind of effect do you think temperature would have on stuff dissolving?
Increase in temperature, increase in solubility.
Okay, maybe an increase in temperature, an increase in solubility? Can you think of an example?
Salt water.
Okay,
Sugar.
salt water, sugar in the sweet tea. Yeah, because you guys know once you ice the tea down, if you forgot to sweeten it, it's just too late, right? The sugar's not going to dissolve in the tea once it has ice in it. So, for solids in liquids, if you increase the temperature, then that will increase the solubility. But something different happens if we're talking about trying to dissolve a gas in a liquid. For a gas dissolved in a liquid, go ahead.
Is that why whenever like the bottom of Coke or something, if it gets hot, it expands, like it gets tight?
Well, that's more of the gas expands with heat because of the molecules moving faster, the volume of the gas expands. But a hot soft drink will go flat quicker than a cold soft drink. So before you open your 2-liter, if you have it in the fridge and you keep it cold, it keeps it carbonated. Okay, if it's room temperature and you open it, it's going to go flat quicker. So for a gas and a liquid, if you increase the temperature, then you decrease the solubility. Another example where you can kind of see that happening, if you have to fill a pan with water and put it on the stove, you're going to boil it for spaghetti or whatever. Do you guys notice that before it starts to boil, if you look in the pan, there's bubbles forming on the sides of the pan? Okay, because there's gas dissolved in the water lines, right? Sometimes we really see that because we'll turn on the water and it'll kind of spurt, right? Because we've reached a gas pocket. And that's what's happening in that pan of water is the gas that dissolves in the water. As you start to heat up the pan before it boils, the bubbles form on the inside of the pan. That affects solubility is pressure. And this is only going to apply when we're talking about a gas in a liquid, because pressure is not going to affect 2 liquids or solids. Pressure is only for gases. How do you think pressure, what kind of effect would changing a pressure have on the solubility of a gas in a liquid, you think? Think about your soft drink, because there's a gas in a liquid, right?
I think more pressure, more solid.
Exactly. The higher the pressure, the higher the solubility. That's why when we open the soft drink and we hear that release of pressure, right? A lot of times that is accompanied by maybe bubbles as the gas is escaping from the liquid. Okay, another thing we want to talk about is different classifications of solutions. You can have an unsaturated solution. You can have a saturated solution. And you can have a supersaturated solution. What do you think an unsaturated solution would be?
It's more solvent than solute.
Right. In an unsaturated solution, there's a lot more solvent than solute, but it also means that more stuff would dissolve if you wanted to. Okay, you haven't reached the solubility limit. So we're talking about salt water, for example. You've dissolved salt in water, and if you wanted to, you could put more salt in there and it would still dissolve because that is an unsaturated solution. What would a saturated solution be then?
It's reached the level. You
Yeah.
can't put any more.
It's reached its limit. A saturated solution has the maximum amount of solute dissolved in solvent. You can't put any more in there. It's not going to dissolve. So a saturated solution has reached its maximum limit. What about a supersaturated?
Fine with the maximum.
Right, you've got over the maximum amount of solute dissolved in a solvent. How would that happen? How would you get a supersaturated?
Too much salt.
But how are you going to make it dissolve if there's a limit to it? Heat. Okay, it goes back to some of those things that we just talked about, and temperature. If you heat it up, you can get more to dissolve and end up with a supersaturated solution. Supersaturated solutions can be very delicate. Bless you. Because sometimes when you cool them down, the solid that you dissolved, it starts precipitating out. You see this happen sometimes at home with jelly that you buy. Have y'all ever gotten the jelly out of the refrigerator and noticed that there's like this, it's white looking crystals? Have y'all ever seen that? No? Sometimes we don't eat ours very fast. And when you make jelly at home, you of course take the juices of the fruit, right? And you boil them and you put lots of sugar in there, okay? And then you can them, you can your jelly, and usually it'll stay nice and smooth, a pretty color, blackberry jelly, whatever it is. But sometimes when you put it in the refrigerator, as it cools down, the sugar precipitates out and you get white crystals. So supersaturated solutions can be kind of delicate.